Meron na naman tayong bagong project. Oy, ano na naman yan? Parang mukhang magulo naman yung ano yan? Ha? Ito, bago nating project. Okay, paano naman gumana yan? Ha? Aba? Eh, lagyan natin ng supply. 5 volts. Para malaman mo. Oh. O yan. Diba? May supply na. Wala namang nangyari diyan. Palpak yan. Teka. Di pa tapos yan. O ito. May dalawang switch. Ha? Pag pinindot ko yung isang switch, release, umiilaw siya. O ano naman ngayon kung umilaw yan? Ba? May isa pang switch. Pag pinindot ko yan, umiilaw din siya. O ano naman ang ano niyan? Eh wala naman yan eh. Aba? Dalawang switch. Pag pinindot mo, umiilaw. Eh paano kung sabay mong pindutin? Ha? Yan o. Ah, sabay. Hindi siya umiilaw. Diba? Pero kung isa lang, yun o. Pindot, ilaw. Pindutin ko yung isa, sabay na. Walang ilaw. Release. Oh. Kabila. Ilaw. Pindot. Mawala. Diba? Pag sabay mong pinindot yung switch, nawawala yung ilaw. Oy, ano naman yan? Yan ang tinatawag na XOR Gate using mga transistor. Oh. Ano yun? Ay, isa sa mga switching circuit yan na ginagamit yan sa paggawa ng computer o ng digital gadget. Diba? O, isa pa. Ilaw? Wala. Ilaw? Wala. Pagsabay, wala siyang ilaw. Yan ang tinatawag na magic. Magic na naman eh. Ordinaryo lang yan. This is the schematic diagram for our circuit. We use 2 buttons. This is a power LED to know that the circuit is on, and we are using 7 transistor. This is the main circuit for XOR gate, and this one, this is a for the LED driver, an open collector type output. We're going to connect the output to the collector of this transistor. We also have the truth table for the circuit. Since we are using an XOR gate, we made this XOR gate, we have this truth table. If both our input is 0, the output is 0. If one input is 1, the output is 1. And both the input is 1, the output is 0. A is referring to switch 1. This is switch 1. B, switch 2. Okay? And then our output, this is the output. Y. 0 referring to the 0 voltage. So 0 voltage, 0 means 0 voltage or low or off. While 1, logic 1 referring to 5 volts because our supply is 5 volts. Also high logic, and also on. That is the meaning of 0 and 1 because we are in digital electronics. What is the purpose of making an XOR gate? This XOR gate is used to design an integrated circuit, or designing a computer or any digital circuit. So we are only dealing with 0 and 1, a binary form or binary number. Because in electronics, usually the digital electronics, it's either low or high, on or off, 5 volts or 0 volts, or just a 0 or 1, no logic level 0 or 1. Okay, and when the input is 0, A means this is 0, and B is 0. It means the switch is not on, or we did not press the switch. That's why it's 0. Because in the circuit, transistor here and the transistor here is grounded through this path R4 to the RA to the R9. That's why it is 0 volts. And switch to B is grounded through R2. So the output is 0. Without pressing the button, this transistor is off because there's no base current or triggering current for this transistor. The current will not flow into the collector to emitter, then collector to emitter to ground. This is off because no triggering current for the base of this. Also, this transistor is off when we have this 0 0 input. How about this transistor? It is, since this is 0 level or off, low, there's no base current. This is also off. Since the switch is open, this is also off. There's no base current to make this transistor to on. From the source to the collector emitter to the ground. How about this transistor? This is off. Even it is directly connected to the source through 5 volts R3 1K, then making this to turn on. It's off because it will not flow into the ground because of this transistor. It is off. There's no triggering base current to the second transistor. That's why it remains off. And because all of this is off, the output is off. That's why if the switch is logic 0, it means it is 0 volts or low, 0 0. The output is 0. It means LED did not turn on, or it is off. there's no current that flows into the collector to emitter of this transistor. I'm using this resistor 100 ohms. This is a current sense resistor, an emitter follower type, because all the current is going to this transistor. All the current flows into the R9 100 ohms, and then with the use of the driver or the LED, a common open collector output, it helps to have a constant current source for the LED, a driver for the LED. We can connect as many LED as we like, as long as it is this the current or the collector current for the transistor is not more than, I think the collector current that can handle for this transistor is around 100 milliampere. So we can connect 5 LEDs, but I think this is around up to 500 milliampere. What I mean by collector current that is capable to flow into the collector to the emitter of this transistor. And LED only consumes 20 milliampere. So times 5, or if this is 500 milliampere, that is the capacity or the capability of the collector current of this transistor. We can connect up to 20 or 10, at least 10 LEDs. 10 could be 5. Now, when the input is 0 for that switch 1, still, since there's no current, no base current, this is off. And then no base current, since it is connected to the switch, is still off. And since it's directly connected to the base, to the supply, it is should be on. But since this is off, there's no base current. Okay, there's no base current for here when they're repairing to the switch 1. And the switch now for B is 1, which means it is on. When it is on, logic 1 means the switch is closed. When this is closed, current flows into this transistor, making this what? Still off, because there's no current for collector to emitter, because this transistor is off, still 0. And for the other transistor, still this is 1 now is on. If this is on, since the collector is connected directly to the source, it's still on, and the current flows into the emitter. It will now inject a current to this transistor, making this transistor to on. This is on, and since it is directly connected to the source, and this one is also on, making the output to turn on, since we have now the current flow from collector to emitter here, collector to emitter, then to the ground, making this transistor to turn on. That's why current now flows into the LED, then collector to emitter, because there is a base current on for this transistor. So when we press the switch B, transistor Q2 is on. And for the other transistor, if this is now 1 and this is now 0, switch on is 1, will make this transistor to What do you think? It is still off because switch B is off, 0. We cannot, the current will not flow into the collector to emitter then to the ground. Still this is off, even the switch is closed because of this transistor. Okay, but we have another transistor. Since the switch is closed, it will make this transistor to turn on. Now this transistor Q3 is on. If this is on, current flows into the 5 volts, then collector to emitter. Since we have base current, now current flows to collector to emitter and to this transistor. So making this to on, to turn on. And since this transistor is always on due to the direct connection, it is directly connected to the source. This is on. So this is on, making the output to turn on 1. So LED turns on because there is a base current for this transistor. There's a triggering current for the base emitter of this transistor, 2N to 2A. Current now flow into the LED to the collector emitter of this transistor. So when the switch A is 1, this transistor is on, and then this one, and this one. Now, in the case that if we both press the two switch, means it is 1 now, and then the B 1, will make the output to turn off. Why? Because when we press the switch, it is the switch is closed here and the switch is closed here with the logic level of logic 1 or high, because we are injecting a current to the base, that is the logic level high, making this transistor, or the current flows into the collector to emitter, then collector to emitter, then to the ground, because this is, we're injecting a base current to this transistor and to this transistor. So the current flows directly to the ground. If it flows directly to the ground, there's no current that flows into this transistor, because they are all directly connected to the ground or flows directly to the ground, making this to turn off. If this is off, what happened to this? This is off because there's no current to flow into the collector to emitter of this transistor, because this is off. So this is also off, because should be the current, it must be the current to flow from 5 volts to collector to emitter, but there's no current here, so this is off. Okay, and how about this one? Even this is on, okay, injecting the voltage or the current to this transistor is still off, because there's no current that flows from this transistor collector to emitter, because this is off due to the switching, or the switch is closed for the switch A and B. So this is off, making this to off. Then what will happen? The output is off, 0. Okay, because there's no base current to the output transistor, so the current will not flow from 5 volts to LED to collector to emitter. There's no light, LED turns off. So when we press the switch, both press the switch at the same time, the output is 0, which means LED is off. This is now our module. Connected is the output LED, red. And into our module, we have the 3 pins. This is ground, out, and BCC. I also added the power LED to know that the circuit is on. This is the power LED. And I added an input LED. Okay? 2 input LED, yellow and green. For the switch one, it is a green LED. When I press it, it will turn on. For the second switch, the yellow, whenever we press the switch, each LED turns on. For the switch 1, switch 2, and if we both press the switch, LED output turns off. While pressing only one switch, it will turn on the input LED and turn on the output. The other one, and again, if we both press the switch at the same time, output LED turns off. So, this is an XOR gate module using transistor.